The distance between the nucleus to outermost electron. The distance from the center of the nucleus to outermost electron is known as atomic radius. So the atomic radius can be measured in angstroms or nanometers or in picometers. So the atomic radius in general, internuclear distance. The half of the internuclear distance is nothing but the covalent radius. If it is covalently bonded, that is a covalent radius. So the distance between the two atoms of different molecules. Two atoms of different molecules. So this is molecule A and this is molecule B. In between there are two atoms, different molecular atoms. Half of the internuclear distance is known as van der Waals radius. The distance between two atoms of different molecules. Between two molecules. Between two molecules. Within one molecule, half of the internuclear distance is known as covalent radius. Between two molecules, half of the internuclear distance between the two atoms of different molecules, A and B molecules, that is van der Waals radius. Van der Waals radius is obviously greater than covalent radius. So van der Waals radius is always greater because it is just side by side interactions and weak force of attraction between the molecules. Of course, this is observed only in solid state, but monoatomic gases like helium, neon, argon, krypton, xenon, radon exhibit van der Waals radius. However, they are in gaseous state. Generally, the van der Waals radius observed in solid state, but zero group elements are monatomic gases. They can experience greater radius. So, if you see the left to right in a period, left to right atomic radius decreases up to halogens and sudden increase due to van der Waals radius of zero group elements. Sudden increase radius is due to van der Waals radius. So, there is a weak force of attraction between the zero group elements. They do not have attractive forces, they do not have repulsive forces. That's why even though they are gaseous state, they can experience greater radius because of weak force of interactions. So in lanthanides, lanthanum to lutetium, atomic radius decreases. Left to right in general, lanthanum to lutetium, atomic radius decreases. If you see the graph between atomic radius and atomic number, the graph is looking like this. These peaks are indicating that some elements abnormally have greater radius than the regular trend. So it is having europium and ytterbium abnormal increase in radius. From lanthanum to lutetium, atomic radius decreases gradually up to lutetium, it decreases. But sudden increase in radius is due to exactly half filled configuration of europium and completely filled orbital of 4f orbital of ytterbium experiences greater radius than any other. So the atomic radius in lanthanides means a group of 14 elements, in which the atomic radius steadily decreasing, but sudden increase in atomic radius is due to 4f7, exactly half filled configuration, and also 4f14 ytterbium and europium exceptionally sudden increase in atomic radius. It is due to their extra stability of electron configuration. But in case of ionic radius, the same elements, lanthanum general electron configuration, if you see, the common oxidation state of A block is +3, lanthanum to lutetium +3 oxidation state. There is a gradual decrease in the ionic radius. With respect to atomic number, if you see the graph, there is no ups and downs. In case of atomic radius, europium and ytterbium abnormal increase in the radius due to their Stable electron configuration. Exactly half-filled configuration of europium and completely filled configuration of ytterbium experiences greater radius than the other elements. Of course it is. However, it is decreasing, but there is no increase here. If you see cerium plus 4, cerium plus 2, lanthanum, cerium, praseodymium, neodymium up to lutetium. Cerium plus 4 means greater positive charge, lesser is the ionic radius. Ions only possess ionic radius, atoms possess atomic radius. If it is ion with a greater positive charge, cerium plus 3, cerium plus 2, cerium plus 4. Among these three, which one have greater ionic radius? Obviously, the lesser positive. Atomic radius inversely proportional to positive charged species. More positive, less atomic radius, which means cerium plus 4 is a less ionic radius. Less ionic radius. Cerium plus 2 relatively higher atomic radius. Less positive, greater ionic radius. More positive, lesser ionic radius. So the radius depends upon the Z effective also. Which one have greater Z effective nuclear charge? Cerium plus 4. Cerium plus 4 acts as a oxidizing agent. Whereas cerium plus 2 acts as a reducing agent. Which means cerium plus 2 trying to becoming plus 3. Whereas plus 4 to plus 3 means gain of electron. Gain of electron is reduction. Loss of electron is oxidation. So that's why oxidation, the element which is undergoing oxidation is known as reducing agent. The element which is undergoing reduction is known as oxidation. So cerium plus 4 becoming plus 3, which means it is acts as a oxidizing agent because it is gaining electron. Whereas cerium plus 2 losing electron becoming cerium plus 3. Increasing oxidation state is oxidation. The agent is known as reducing agent. So any reducing agent does reduction but itself undergo oxidation. Any oxidizing agent does oxidation but itself undergo reduction. A oxidizing agent does oxidation but itself undergo reduction means cerium plus 4 undergoing reduction. Cerium plus 2 undergoing oxidation. But the agent is reducing agent. Oxidizing agent. Sometimes they will give ionic radius. So it is a gradual decrease. It is due to the continuous electron. The 14 electrons enter into same sublevel. That's why the lanthanoid contraction is observed. Lanthanoid contraction. Of course, it can be observed in actinides also. That may be called actinoid contraction. But if you compare lanthanoid contraction and actinoid contraction have greater effective. So anyway, top to bottom atomic radius increases. In case of lanthanum to lutetium, these elements are very special. They are asking in the JEE examinations. Europium abnormal increase due to their stable electron configuration. Ytterbium also same, completely filled stable electron configuration. Is it clear?